Okay guys, this is part 2 of calculating I time based on flow. So just to recap from part 1, we had recognized that in able to get an equation that we can work with, we needed to make sure that our time was in seconds versus minutes. And that our volume that we're working with, so our time, we wanted to change the 60 liters per minute to something per second. And we wanted to change the liters to milliliters to deal with our tidal volume and our I time. Those are more convenient units to work with. So what we did is we said, well, if 60 liters per minute are flowing out, I can divide that by 60 seconds in a minute, and that gives me 1 liter per second. And 60 liters per minute equals 1 liter per second. And then I said, well, we're good on units now. But we're good on time units, but can we change our unit of volume? Sure. We want to go ahead and work with milliliters here. So 1 liter per second is going to be equivalent to 1,000 milliliters per second. So all three are equivalent statements. 60 liters per minute equals 1 liter per second equals 1,000 milliliters per second. All three equivalent statements, but this one has the units that we want to work with. Okay. So now, I can go ahead and just set up a dimensional analysis and I can say, all right, 1,000 milliliters in 1 second. Everyone would agree that that's the flow that we're dealing with. But I want to give 500 milliliters. That's my tidal volume. So I want to give 500 milliliters. And I want to know how much time it will take, because that was the entire question is, what is my I time? And, of course, my time is x. I don't know x. But x, we'll just put here, is the I time. So now this becomes a real simple problem. Cross multiply. 1,000 x equals, so we're cross multiplying, 1 times 500 is 500. What do? I divide both sides by 1,000. X falls out. Divide this side by 1,000. We know we can knock out some zeros here. 10 goes into 5. How many times? Well, 10, 5. I can go ahead and add a 0, but then I need to add a point up here. 10 goes into 50 how many times? 10, 20, 30, 40, 55 times, 0.5. So, that is our, hopefully everyone can see that, our I time. 0.5 seconds. So, at 60 liters per minute, it will take 0.5 seconds to deliver a 500 milliliter tidal volume. So, in fact, I am able to retrieve the inspiratory time based on flow and volume alone, because time is a function of flow, and flow is a function of time. The fundamental unit of flow is a liter per minute. So time is one of the fundamental dimensions of flow. So hopefully that makes sense, that when we get these flow problems, what we first want to do is we want to convert our flow into a unit that is reasonable to use. And it's reasonable to look at milliliters because I'm dealing with a milliliter tidal volume. You could use liters as well, but you would just have to convert your tidal volume to liters. Either way you look at it, you want to convert both things into the same units. If I either both milliliters or both liters, I just tend to go with milliliters because that intuitively makes more sense to me. And then you deal with the same units, and through logic, we realized that we're probably not going to be dealing with an inspiratory time of minutes. So we went ahead and converted the minutes into seconds. And we just did that by reasoning that if I have 60 liters a minute, that's going to be 1 liter a second, 1,000 milliliters per second. All three are equivalent statements of flow. Once we got the right units, we simply set up a dimensional analysis, solved for x here, and got our I time. And we could do that with any flow, in any tidal volume, we could calculate any I time. Okay, guys, hopefully that helped out a little bit and that makes some sense. We'll see you in the next video. Take care.